You're listening to the Things Podcast, brought to you by the Things Industries.
All right, welcome to the Things Conference podcast. We are here in Amsterdam, second day of the Things Conference. I'm Mark Poos, Developer Relations at Edge Impulse, co-founder of IoT Stars. And I'm here with Thomas from NeoCortec. And how are you? How was the first day, basically, yesterday?
Yeah, thank you. So actually, this is our first time at the conference. So since this year, they opened up for let's say other technologies than LoRaWAN. So really exciting for us. It's great to be here. There are lots of people attending and very, I say, knowledgeable people. Have a lot of great conversations with the visitors. So yeah, so far really great.
Please, Thomas, introduce yourself and your company.
Right. Yeah. So my name is Thomas. I'm heading up NeoCortec, which is a Danish company who's been in the market since 2014 with our protocol stack, which allows you to build highly scalable mesh networks, low power, completely decentralized. So we've been doing that, as I said, since 2014. Basically maturing the stack over the past 10 years, and now, since a couple of years ago, we started applying it to the LoRa physical layer. So not LoRaWAN, but meshing over LoRa.
Tell me more about mesh networks. I love this. Tell to the audience the mesh network.
Yeah, so I mean, typically or traditionally, a mesh network would be built on the principle of having like a hierarchical structure, different types of devices in the net. So if it's a Zigbee net, if it's a Bluetooth low energy mesh, if it's a thread mesh, basically all of them rely on the same core principles of having dedicated device types who are responsible for certain activities. So you can have a coordinator who sets up and organizes the network, and then you can extend from him out from there with routing devices, and then ultimately you can have end nodes who can be low power. So that's sort of the same core principle. Then they do things slightly different ways, but that's sort of the way they do it. With NeoMesh, we have a single device type. So everybody can route data, which is really important, because then basically all the devices that you, let's say, set up in a setting like this, for instance, are, let's say, participating in the mesh and not just being, let's say, a blind passenger, if you like. We don't have any centralized coordinator. Everything is distributed into the participating devices. And then finally, it's a time synchronized network. So the devices will go to sleep and wake up at predefined schedules, which means that is
Literally how like a real-time plot, but they need to be synchronized.
yeah, they're very tightly synchronized to each other. And then that allows us to have a very low average current consumption for the participating mesh, even them being fully functional devices.
So Thomas, on the network topology, so what do you need? So the gateways are different, or do you need gateways, or just and devices as you described are enough?
So it's a great question, actually, because in many systems, the gateway, beyond just being, let's say, an entry point in and out of the network, also takes an active part in organizing the network. So we don't need that. So we can have a gateway, obviously, if you want to have something which communicates with a cloud or whatever. But the network doesn't rely on the gateway. So you can have a fully autonomous network, and we do have customers who are using the mesh to build something which is completely decoupled from the rest of the world, really, and don't have any single point of failure, which is important.
So tell me more. Why did you decide, this year or last year to start merging your mesh technology with LoRa?
Yeah. So for us, what LoRa does is, I think many people think LoRa gives you long range, which it does to some extent, but mostly that comes from the lower bit rate and the higher sensitivity of the radios. But the LoRa modulation actually gives you the ability to perform really well in noisy environments. So you can have a negative signal to noise ratio with LoRa, whereas with regular FSK you have to have a positive signal to noise ratio. So in many situations, like in a building or in some setting, usually the range is not limited by the radio sensitivity. It's more so the noise that you have in the area. So what we saw was that in some applications that could be an advantage. If you think about, for instance, 2.4 gigahertz being a really, let's say, popular frequency band because it's global and it's available. But there's also a lot of things happening there, so a lot of noise. So typically we wouldn't be using 2.4, but with LoRa, we are actually now seeing some interesting opportunities for meshing on 2.4 LoRa. But again, if you do sub-gigahertz, you get even longer range. So think about things like smart agriculture, foresting, things like that, where you can benefit from the really long range that you get.
So these are the use cases that you see where some of the mesh and the LoRa are getting out of code.
Yeah, I think that, LoRaWAN has been great and is still great for many applications. But you have the star topology limitations. So if you have a device, let's say inside of a building, deep indoor, underground, who cannot reach the gateway, then the only fix is to add more gateways, which is a costly thing to do. So
Yeah.
with the meshing, you don't have to do that. The devices become the network, essentially.
And just to clarify, so what's the business model of your company?
Yeah, so since our technology is essentially software, we license that on a per device basis. We engage now with module manufacturers to license our stack to them for those to integrate it into their modules. So that would be sort of the easy way to get access to our technology to buy one of the modules. But of course, we also work with customers to license the stack directly into the product.
Okay, if I'm not wrong, yeah, there is a podcast with NB, where you're partnering.
Correct. Yeah, basically correct. Exactly. Yeah. So Mbit is actually the first one taking NeoMesh on LoRa into the market on a module. So we're really excited about the partnership with them. We already have a lot of interesting opportunities that we are working towards, but more will come. So yeah.
And Thomas, how do you see the future of this field industry?
Yeah, so I mean, there are two answers to that question, I guess. Because one thing is we've only just started with the LoRa journey in a way, and I think LoRa on its own is also evolving. Semtech is doing a lot of stuff to add more capabilities to the LoRa modulation. So we will see where that takes us. Maybe higher bit rates on the LoRa physical layer will help to bring down current consumption in a mesh network even further. So that's one thing that we are looking for. On NeoMesh as a core technology, one of the things that we are really focusing on is a higher integration with higher level protocol stacks, so IP integration, but also management tools to monitor the networks as you distribute them.
Yeah, because this is relevant, right? You have to monitor your network to understand that everything is connected.
One of the things that NeoMesh does really well is that it deploys real easy. So you don't have to do a lot of planning when you put the network inside of a building or in a field or whatever. But then you leave it there. Let's say it runs for the next 10 years on a battery. Then you have to think about over the duration of those 10 years, things can happen. The building can change over time, or whatever. So the environment in which the network is operating can change over time. So we need to have tools that monitor that. Most of the time, the mesh will adapt to that, but there can be the case where because of physical obstacles that there's no way around it and you may need to go and adjust something.
Really cool. So how to contact you if a company wants to learn more about the NeoCortec technology?
We are very modern. We have a website.
Okay.
Yeah. So I think that's probably the easiest way to get access. Yeah.
Fantastic, Thomas. Nice to meet you, and a lot of success. Yeah, thank you. So see you at the next podcast. Bye.